Welcome to the AI Research Roundup. I'm Alex. Today we're looking at a paper from the Hugging Face trending list, published on September 17, 2025, just yesterday. The standout result is that targeted machine unlearning can scrub sensitive memorization from code models, with the proposed method achieving a 93.89% reduction on the forgotten set while keeping utility essentially intact. The paper is titled, "Scrub It Out, Erasing Sensitive Memorization in Code Language Models via Machine Unlearning." And as we will see later, the implications for safe deployment are quite significant. In short, the study quantifies sensitive leaks, curates 50,000 high-risk samples, and shows a selective unlearning recipe that removes secrets while preserving surrounding code behavior and performance. Also, the authors shared a GitHub repo. You'll find a full PyTorch implementation of CodeEraser, scripts for detecting and quantifying sensitive memorization, data crawling tools, unlearning pipelines, and evaluation on CodeParrot, CodeGen, and QN models. There are setup guides, CUDA and dependencies, caching scripts, and ready-to-run examples. Figure 1 contrasts 3 ways to handle sensitive code in deployed models, and it highlights why post-training unlearning is attractive. Data deduplication and differential privacy both require full retraining, which is costly and slow. Machine unlearning instead edits the trained model with gradient-ascent, which means pushing the model to assign low probability to targeted samples, so specific secrets get scrubbed without broad damage. The cartoon also ties this to write-to-be-forgotten requests from users. Table 1 explains how the authors score memorization using 2 measures, so it grounds the later claims with a concrete example. Memorization accuracy means token-level recall, which counts how often the model's next token matches the true token. Extraction likelihood means n-gram overlap, which checks whether short sequences line up, making it a stricter test. The table walks through one sentence, showing token matches and 3-gram overlaps to compute both scores. So, figure 2 shows how strongly sensitive strings were memorized, which means how often the model predicts the exact next token of a secret when prompted with nearby context. The vertical dashed lines mark the memorization thresholds that separate benign from risky cases. The top histogram for CodeParrot small places many samples near 1, so a sizable tail breaches the threshold. The bottom histogram for CodeGen 350 million mono shows a similar pattern, which indicates that roughly 7% of samples cross the risk line. So Table 3 reports how well the unlearning actually erased sensitive memorization, which matters because success means scores drop below risk thresholds, while utility stays intact. This table lists 4 metrics, with memorization accuracy and extraction likelihood at 3, 5, and 10 tokens, and a reduction rate summary. Across model families, CodeEraser consistently brings values beneath the bold thresholds. For instance, on QN 2.5 Coder 7b, the reduction rate reaches about 94%, indicating strong targeted forgetting without overdoing it. Alright, 2 takeaways stand out. Targeted machine unlearning can reliably scrub secrets from code models, and selective editing preserves utility, so models stay useful while risky strings vanish. The broader implication is practical compliance and safer deployment without full retraining, which lowers cost and turnaround time. That is it for this episode of the AI Research Roundup. I am Alex. Thanks for listening.